samples, well, we have independent versus paired samples. Anyone remember the difference between independent and paired? Alexis?
Independent doesn't affect each other, while paired is simply like before and after.
Yeah, exactly. Independent, they don't really affect each other. Observations in one sample have nothing to do with any observations in the second. Paired samples, you can like literally pair them up. Like usually the sample sizes are the same. You can kind of like see how they line up together. Okay. In 11.1, we dealt with independent samples, but we did kind of talk about paired. 11.2, oh, we kind of skipped. And 11.3, we're going to talk about paired samples. Okay. Remember, our quiz is on both independent versus paired samples. So that's something you might want to think about. Okay. Last class, we filled out this chart that kind of just showed us the difference between one sample and two sample hypothesis testing. If you don't have the chart, the same chart is filled out for 11.1. So you'll still have that. And then we talked about kind of the steps that we would follow for paired samples, pretty much the same, except we're going to use a different hypothesis or different Minitab test. Okay, so instead of using the two sample t-test for independent samples, we're going to use the paired t-test for paired samples. Okay, let me just see. Drink something. Okay, so once we finish this, then pretty much everything is the same. All right, we have one example that I want to go over. Once we're done this example, we'll move on to the quiz and then we'll be free to go. Okay, now if you are thinking about the quiz, pay attention because this is going to be very similar to something you might see later today. Okay, so let's just go through this one and then we'll put it all together in the quiz. Okay, so we have a sample of 5 third graders and they are all taking this reading test. Okay, after they did that, they participated in a reading improvement program. So they learned some stuff and they got a little bit better. And then they took the test again to determine if their reading ability has improved. Okay. So following are the test scores of each of the students after and before. I know it looks a little weird how after is on top, before is after. Don't worry about that. Okay. And we're going to ask ourselves if the mean reading score has increased after the program. Okay. We're going to use a significance level of 0.05 and we'll see how we go. Okay. So, okay. Before we go on, I just like to write down our information. When we have paired samples, there's really not much we have to write down. Okay. All we really have to do is write down what sample 1 is and write down what sample 2 is. Say, okay, which one do they represent? Okay. So sample 1, sample 2. And I know it seems kind of counterintuitive, but just because after was like introduced first, like it's on top, I'm gonna make that sample 1 just so it's first. I don't know. I'll make that after. And sample 2 will be before. Okay. So before we go on, can someone tell me what N1 would be? Yeah, 5, right? Because there are 1, 2, 3, 4, 5 things for the after row. Nice job. And N2 is also going to be 5, right? Okay. All right, so step 1, we are going to check our assumptions. On the quiz, I'll write down like what the assumptions are. The first one is, do we use the 2 sample? No, gosh. Or do we have independent or paired samples here? Paired, right? Because, well, it looks like student 1 has an after and before. Student 2 has an after and before. And you can kind of pair each of these together, right? So this is definitely paired. Okay. Second, I think the most important kind of assumption to make here is, let's take a look at the sample sizes. Looks like the sample sizes are 5. Is 5 bigger than 30? No, right? So 5 is not bigger than 30, which is usually a bad thing, means we can't go on. Anything in the question that tells us we can still go on? Actually, you know what? I don't actually think it's in the question, is it? Does anyone say anything about a normal population? No, right? So how about, let's do something here. we're going to add something in the question so we can go on. Let me just add that the population is normal. Okay, let's just step back and pretend that was there. I know it seems kind of sketchy that I did that, but that's okay. Now, is there anything in the question that says we can go on? Yes, right, the population is normal. So even though the sample size is not large enough, the sample size is normal, or the population is normal. Okay, now I'll never give you a question where you can't go on, so don't worry about that. But at least we have that assumption there. Okay. Next, step number 2. We're going to state our null and alternate hypotheses. Null hypothesis, what symbol does that use? Good, H0, and I guess the alternate one is H1. Okay, the null hypothesis always uses mu, right? So does the alternate. And the null hypothesis, well, we have 2 means, right? So I guess we need mu1 and mu2. Okay, null hypothesis always has an equal sign, so that makes it pretty easy for us. Okay. The alternate hypothesis always has the same sort of deal here, but instead of an equal sign, we're going to have a less than, greater than, or not equal to sign. Who thinks it's, I don't know, greater than? Who thinks it's less than? Okay, anyone want to explain why it's less than? Anyone want to explain why it's greater than? I'm going to tell you. I'm going to tell you it's, gosh, greater than. Even though it says increase after, okay? The reason I'm saying this is because I looked back at the question. I said sample 1 is after, sample 2 is before. I know it looks counterintuitive that it increased after the program and the greater than is going like that way. But because I kind of switched around what sample 1 was and what sample 2 was, the sign has to go in the direction where it is bigger. Does that make sense? Okay. I'll try really hard not to trip you up on a question on a test or quiz, so don't worry too hard about that. But for this question, it's a little bit hard. Okay. Okay, number 3, we're going to ask us what the significance level is. Alpha in the question, let's see, says it's about 0.05, right? Okay. Next, it's going to ask us what the confidence level is. Confidence level. Anyone remember the formula for the confidence level? Uh-huh. Good, 100 times 1 minus alpha. Okay, so when we find the confidence level, all we have to do is just plug in alpha. Okay, so 100 times 1 minus 0.05. Okay, once we do that, we can subtract. So it becomes 100 times 0.95. And when we multiply that by 100, we get 95. Okay. So remember for your quiz, memorize that formula, 100 times 1 minus alpha. Might need that later in class. All right, going over to Minitab. I'll show you how to do this, okay? First of all, we're going to type in all our values into Minitab. So when a question gives us like the sample mean, sample standard deviation, stuff like that, that's when you have to go in and like type in what they are. When they give you the actual data values, you're going to go into C1 and C2 and type in all the values underneath each of those columns, okay? After we do that, we're going to click on paired T. I'll show you how to find that. We'll type in C1, C2, and click options, do a bunch of stuff, and we'll get a P value. Let me show you how this works. All right, I'll turn on Minitab. Let's see. Okay, now we have to share this screen. Okay, so just like I kind of explained, the first thing I'm going to do is just type in everything into C1 and C2. So since after is C1 or sample 1, I'm going to put 67, 68, 78, 75, 84. Oh, that is not C1, that's row 1, isn't it? Didn't pay attention. Okay, 68, 78, 75, and 84. Okay, under C2, all right, 59, 63, 81, 74, and 78. Okay, once I'm done doing that, I'm gonna go all the way up to stat, basic statistics. And so far, all we've used are these four, the one sample Z all the way to paired T. Since we have paired samples, of course, paired T is what I'm clicking. Okay. Once we've done and clicked paired T, we're going to keep this. We have different things. For paired samples, I'm never going to give you the summarized data. So we're just going to click each samples in a column. Sample 1 is C1. Sample 2, C2. Okay. I know it's very tempting to click the OK button, but before we click OK, let's just hit options and see what we need to change up here. Okay. The confidence level is what we calculated in step number 3, so 95. The hypothesis difference, don't worry about this. Let's just keep this at 0. Okay, so don't touch hypothesized difference. Alternative hypothesis is the symbol in the alternative hypothesis. Okay, so since we used a greater than symbol, I'm going to go and click greater than instead of not equal to. Okay, this does change up your p-value. So if you're getting something wrong on Connect Math, you might need to go and check to see if you click the options button. Okay. We'll click OK and OK. I'll make this a little bit bigger. Let's see. Oh, wrong thing. Make bigger. Nope. Okay. Maybe it wants to make. Okay. You know what? Maybe we won't make it bigger. But if we scroll all the way down to the bottom, it'll tell us what our p-value is, which is what we're looking for. Any questions on Minitab? Good. All right. So okay. So it looks like what we got matches what the question gave us. Oh. We're going to make this full screen. Okay. So it looks like we got 0.079 as our p-value. So that's what I'm going to write down. Okay. Step 5 asks us if we reject or fail to reject the null hypothesis. We do that by comparing two values. Which one are they? Good, P and alpha. I always like writing P on the left, alpha on the right, just so they kind of stay the way that they are. 0.079, alpha in the question was 0.05. Which one was bigger? P, good. So do we reject or fail to reject? Is it reject? Yeah, fail to reject. I know it gets kind of confusing after a while. Fail to reject the null hypothesis. And our conclusion consists of two parts, right? The first part of the sentence is going to say, we conclude or not enough evidence. Which one is it? Not enough evidence, good. There is not enough evidence to conclude that, okay? And what is the sentence going to end with? H1, the alternate hypothesis. So just taking a peek back to the alternate, it says mu1 bigger than mu2. So that's literally what I'm going to write. Mu1 bigger than mu2. And that's all we do for these sorts of questions. Okay. Any question on this example? Cool. This is what we're doing for the quiz. Okay. So make sure you take a look at what we just did. Our quiz will be pretty much like this. So take a look. And well, I guess it's about quiz time.